Hello all. This video is the fourth part of the statistical problems in community medicine. We are going to discuss about the purpose, the steps, how are we going to interpret the chi-square test. Throughout this process, we are going to learn so many important points about types of errors, types of hypothesis, then what is p-value and many more. So carefully watch till the end. You are going to gain knowledge beyond the calculations of chi-square test. And this one test we are going to do from top to bottom with proper understanding, so that this chi-square test is going to be one example for all the statistical tests which you are going to understand. The type of variables changes, and based on the type of the variables and its distribution, the choice of statistical test also changes, but the inference is going to be the same. So that is what we are going to see in this video. Before moving to the chi-square test calculation, let me make you clear about the fact that what is the purpose of chi-square test. In order to understand that, we should know about the types of variables first. For statistical analysis purpose, you just register in your mind that we have two types of variables, that is categorical and numerical. Categorical is like we have this gender, male and female, or all your pass and fail, present and absent, all will be under categorical variable. Numerical variable means numbers such as hemoglobin, height, weight, BMI, all comes under this numerical variable. This is a broad classification of the type of variable. Under each type we have subtypes. That is, under categorical variable we have nominal and ordinal. That is, for ordinal there will be a rank order, but for nominal it is just a name. For example, gender, blood grouping, all comes under nominal category, whereas your ordinal variable means it follows a rank order. All your mild, moderate, severe, all comes under this categorical variable, that is ordinal. Now we move on to the next type, that is numerical. Here we have interval and ratio. That is one way of classification. The other way is discrete and continuous. So interval means there will not be a equal spacing between two variables, but for a ratio scale, it will be like weight. In case of weight, it means 10 kg weighs double that of 5 kg. So if there is a proper zero, then you can call it as a ratio scale. That is weight, height, and all will be example. On the other hand, interval scale, the example will be temperature. Same way here, discrete and continuous variables are there, where we have the total number of family members will be considered as a discrete variable. So there will not be any decimal in between. But in continuous variable, there will be decimals in between. For example, hemoglobin is a continuous variable. But for statistical analysis purpose, you need not remember all these classification. You have to remember only the categorical and numerical types, and you need to correctly classify into categorical and numerical types simply. Why we are understanding this types of variables before chi-square test? Because we are going to use chi-square test for comparison of two categories. When we are comparing two categories, that is, we are comparing one category with other category, then we use this chi-square test. That is, for example, smoking and lung cancer, the classical 2 bar 2 table, if we are comparing, then we use this chi-square test. So this is the first thing which we need to understand. That is the purpose of chi-square test. It is a test of association between the two categorical variables. That is why we should understand the types of variables clearly. What is a categorical variable? Because we are using chi-square test for comparison of two categorical variables, or to study the association between two categorical variables. Then we need to understand about what is the hypothesis. We have two types of hypothesis, that is null hypothesis and alternate hypothesis. Null hypothesis means nothing, or we will denote it by zero. That is, it says that there is no association. Whereas the alternate hypothesis or research hypothesis says that there is an association. It will be written as H1, and null hypothesis will be written as H0. So it says there is an association between two variables. So we always try to disprove this null hypothesis in statistics rather than trying to prove this alternate hypothesis or research hypothesis. So how this null hypothesis can be true when we reject it? So that's what we are going to see in any statistical test. So for that we should know the types of error, that is alpha error and beta error. For this we will go into the next slide in order to understand the types of errors. So in any situation, the null hypothesis can be true or false. There are two possibilities for null hypothesis. One is it can be true or it can be false. And in your study result, you have two options for it. Either you can accept it or you can reject it. So when you accept the null hypothesis when it is true, that is a true positive, which means that it is a correct verdict. On the other hand, when you have rejected null hypothesis when it is false, that is also the right verdict, that is called a true negative. On the other hand, we have a situation of falsely rejecting it and falsely accepting it, that is called a false positive and false negative. So this situation where we reject the null hypothesis when it is actually true is called alpha error. On the other hand, when we accept the null hypothesis when it is false is called beta error. So the mnemonic here, how to remember this alpha error is, you have to remember ART. It is alpha error is rejecting null hypothesis when it is actually true. Alpha error is rejecting null hypothesis when it is actually true. The reverse is beta error, which means beta error is accepting null hypothesis when it is false. As we say, these two are the correct decisions. These are the errors which we make, and this is the alpha error, and this is beta error, that is rejecting the null hypothesis when it is actually true is called as alpha error. Accepting the null hypothesis when it is actually false is called as beta error. So the probability of committing this alpha error is called as p value. Now many people will not know what is p value. They want to calculate p value for their research, but they will not know what is p value. And I am going to be the eye opener for them. P value is the probability value. What is the probability? It is the probability of committing the alpha error. Now we can simply say p value is probability value, probability of committing the alpha error. Otherwise, we can expand and say it is the probability of rejecting the null hypothesis when it is actually true is called as p value. We can expand like this and we can tell. So that is the alpha error and about the p value. Now beta error, the inverse of this beta error, that is 1 minus beta, is called as the power of the study. Many people will calculate power of the study at the end. So that is nothing but the 1 minus beta, that is inverse of the power of the study. Now we have mentioned about the purpose of chi-square test earlier. Now we are going to cross check it and we are going to identify it whether it is correct or not. That is, it is used for testing the association between two proportions or categories. So here male and female is a category and pass and fail is a category. So we are comparing these two category, hence chi-square test will be the correct choice. So here is one example for the right place where you can use the chi-square test. Now we move on to the actual steps of chi-square test. First step is stating the hypothesis. That is, we need to mention about the research and the alternate hypothesis. Few minutes back, we have learnt about what is null hypothesis and what is alternate hypothesis. The null hypothesis says that there is no association between the two categorical variables, whereas your alternate hypothesis or research hypothesis says that there is a relationship or association between two variables. We need to mention that first. That is the first step of chi-square test, the mentioning or stating the two hypotheses, that is alternate and null hypothesis, clearly first. Then the second step is the calculation of the chi-square value. This is the most important, difficult and lengthy step in calculation of chi-square test. It looks similar to the standard deviation calculation. So you should not confuse between the standard deviation calculation formula, but here it is the calculation of the expected values of the each cell first. Then we need to calculate the chi-square value. So how are we going to do this? So here is an example for calculation of the chi-square statistic from the sample data. So now we have smoking and lung cancer, which are the two categories represented as yes and no. So the first step is to calculate the expected frequency. All the values here are the observed values. Observed values. We need to calculate the expected values for each of these cells. In order to do that, we need to calculate by this formula, that is for each cell the numerator will be multiplication of the column total and the row total divided by the grand total. So for each cell we have to calculate by the formula, that is row total into column total divided by grand total. That is how you should calculate the expected frequency or expected value of a particular cell. For example, in this cell, we need to calculate by multiplying the C1 and R1 divided by N. So that is how we calculate the expected value of the each cell. So like that, I would recommend to make a table for this that will make your work easy. So you will not get confused in calculation. So we will put all the cell names as A, B, C, D instead of 1, 2, 3, 4. So all the observed values are written here. Then expected values we need to calculate. So that is how it is calculated. So it is for this cell, it is 40 into 40 divided by 70. So which means 160 divided by 7, which will yield about 22.8. Same way, all the cell values have been arrived by multiplying the row total into column total divided by grand total. Then once this expected value is calculated, we need to calculate the observed minus expected. Then we will get the observed minus expected value like this. Then we need to square it off. We need to calculate the observed minus expected the whole square. Then we need to divide the observed minus expected whole square divided by expected. We will get a particular value, and we need to have a summation of this observed minus expected whole square divided by expected. So we will get a particular value, and this value is called as chi-square value. As I told, chi-square value calculation is the most important, difficult, and lengthy step of calculation of chi-square test. So what we are going to do here is we are going to calculate expected values for each of these cells by this formula, that is row total into column total divided by grand total. Then once we calculate it, we are going to put a table for this. So this is the observed value, this is the expected value we have calculated using this formula. We have calculated observed minus expected, we have calculated observed minus expected the whole square, then observed minus expected whole square divided by expected. When we do a summation of this, that is sigma observed minus expected whole square divided by expected, will be the chi-square value. So we have got a particular value called chi-square value. There is one more easy formula for this. So that is, you can calculate the chi-square value by AD minus BC whole square into grand total divided by C1 into C2 into R1 into R2. So this is one shortcut formula which is not routinely given in the book. So you can use this formula to get the chi-square value. So you can put directly substitute the values here, and you can do this chi-square value calculation. So we are done with the second step. That is, we have completed the stating of two hypotheses, and we have calculated the expected values of each cell, and we have calculated the chi-square value also. Now we are moving to the third step, which is also a easy step, that is the calculation of degree of freedom. That is, you can straight away write saying that for 2 bar 2 table, the degree of freedom will be 1. Like that you can write directly, or you can use this formula to calculate the degree of freedom, that is column minus 1 into row minus 1 So we have 2 column minus 1 into 2 row minus 1. So 1 into 1 will give 1. So this is the formula. What it means is, in any 2 bar 2 table, suppose we have values like this. If we have all the row values, column values filled up, only one cell value will make all the other values to get filled. So this one cell only will fill up the entire table. So likewise, if the number of column and row increases, the degree of freedom also differs. So for that, this calculation is used. So we can put up this formula again in 2 bar 2 table as 2 minus 1 into 2 minus 1, and we can yield the same degree of freedom. Or straight away you can write, for any 2 bar 2 table, the degree of freedom is 1. So that is the third step. And the last and the most important step is the cross checking with probability table. That is, for 2 bar 2 table, degree of freedom, the critical value of p value less than 0.05, the test value should be 3.85. How did we arrive this sentence? Is by this probability table, which we have it in our textbook. In health information statistics chapter, it will be there. You have to remember one particular value only. I will explain what it is. So in this table of chi-square for probability, they have given the degree of freedom here. So they have given the degree of freedom in ascending format, that is 1, 2 to 3. So we are going to deal with only one, the first degree of freedom only, because in calculation in exams you will get only 2 bar 2 table. So you have to look at only the first row. Then we all know the p value, that is the probability of alpha error, is the arbitrary value, that p value should be always less than 0.05. So this is the most critical value. So when the p value is less than 0.05, we say that there is a significant difference between two groups is present. So we have to look at only this 0.05, and correspondingly what is the value of chi-square that we should look. So this is 3.84 we have obtained as the chi-square value for degree of freedom 1 and 0.05. If you carefully look at, as the p value decreases, the chi-square value increases. So as the p value decreases, the chi-square value increases. So we can say, when the chi-square value is greater than 3.84, the p value will be less than 0.05. So that is what we infer from this probability table. That is, the chi-square value is greater than 3.84, you get p value less than 0.05. So that is what it is written here. For 2 bar 2 table, that is for degree of freedom 1, for the critical value of p value less than 0.05, the test value will be greater than 3.84. Suppose in our calculation of chi-square we get more than 3.84, then we can say p value is significant or less than 0.05. When the p value is less than 0.05, then the last step is whether to accept or reject the null hypothesis. Now you need to understand what is p value. P value is the probability of rejecting the null hypothesis falsely. That is the probability of alpha error. That is the false rejection of null hypothesis. The probability of falsely rejecting the null hypothesis is almost nil. So you can reject it. So that is what we, from this chi-square calculation and these steps, so we are obtaining the p value less than 0.05 as a significant value in order to say that we are not falsely rejecting it. The chance of we falsely rejecting the null hypothesis is very, very less. The chance of we committing the alpha error is very, very less. So that is why the chance of we falsely rejecting is very, very minimal. So we can we can reject the null hypothesis with this p value. That is what we do in chi-square test. So to sum up, in chi-square test, for the background knowledge of chi-square test, we have seen about what are the types of variables. There are two types of variables, numerical and categorical variables. And chi-square test is used for comparison or association between two categorical groups. Then we have seen about the two hypotheses, that is alternate hypothesis and null hypothesis. Null hypothesis says there is no relationship. Alternate hypothesis says there is a relationship. And we have seen about the types of errors. That is, alpha error is rejecting null hypothesis when it is actually true. That is falsely rejecting the null hypothesis. And the probability of committing it is called as p-value. Whereas the beta error is falsely accepting the null hypothesis when it is false. And the inverse of it is called as the power of the study. Next, we have seen about the steps in calculation of the chi-square test. First is stating the hypothesis. We need to state the null hypothesis and alternate hypothesis. Then second step, which is the most important, lengthy and difficult step in calculation, from the observed values, the row totals and the column totals and the grand total, we need to calculate the expected value. We need to calculate observed minus expected. We need to calculate observed minus expected whole square. We need to calculate observed minus expected whole square divided by expected, and we need to summate it, and the summation is the chi-square value. And that chi-square value we need to keep for some time. Then we need to calculate the degree of freedom. For 2 bar 2 table, it is always 1. We can write straight away like that, or we can use this formula rho minus 1 into column minus 1, and we can arrive 1 as the degree of freedom. Then we need to look at the probability table. That is this table. We all know the value, that is 3.84 is the critical value. And when the chi-square value is more than 3.84, we always get the p-value less than 0.05, which means when the chi-square value is more than 3.84, the probability of V committing the alpha error is going to be less. That is, the probability of V going to falsely reject the null hypothesis is very, very less. We are not falsely rejecting it, we are rightly rejecting it. So we can rightly reject the null hypothesis, and thereby we can accept the alternate or research hypothesis. Hopefully, you have got a clear-cut idea about chi-square calculation and the p-value and many more concepts for a statistical test. Hope this video was very useful to you. If you like this video, please click on the like button and share it to your friends. If you haven't subscribed to the channel, please subscribe. Thanks for watching.